And in that video, we'll finally build a real physical robot driven by the LLM on its back. Our robot will be trolley from the trolley dilemma. You probably know that problem where you have a train running down the track at full speed and need to choose even left and run over someone, or right and also run over someone else. The point of all dilemma is to choose most moral way to go to minimize the overall loss. Train dilemma is actually the simplest problem I came with, where we need our LLM to solve it. It couldn't be solved by simple classical algorithms. To solve that dilemma, I bought a toy train on which I will install the Raspberry Pi with special engine controller, you can see here, that will be actually driven our train engine, not right or left, but front or rear. That cheap train set has no anyway switchers. So first thing I'm going to do is to install our engine controller on the top of Raspberry Pi. Using my solder station, I will remove the unnecessary cables from inside of my train and will connect it to the engine controller. Let's connect it this way, where cables from train battery going to fall in connector and cables to train engine going to one of that connectors to control the engines. And next thing, we'll be writing appropriate program to control our Raspberry Pi. But first let's discuss a prompt I created for our trolley. It depends with simple instruction that he is actually a trolley. He needs to choose if he needs to go right or left. At both sides we have right and left object variables, which are in curly brackets, so in long chain we can swap that pieces of text with a variables. And providing task for him to choose the best ethical option. And after that we also providing a response format and asking him to output in XML. Usually we use an XML or JSON format to be able to format the LLM's output and easily retrieve needed parameters. So actually in that XML we first asking LLM to provide reasoning, to think about which direction to choose. Reasoning is a really important part of every LLM application, which increases the quality of the LLM responses. And after that we providing a decision where we asking him to return either right or left. Let's try to test that prompt locally in my PC. Let's run our model in Ollama. And as we see, it outputting its reasoning, and after that outputting decision. He preferred to hit a child instead of two old persons. In my RTX response was generated in seconds, but in the Raspberry Pi it will take minutes to generate. Now let's go step by step through main script of our trolley. First of all, here we are initializing our LLM, which is based on Ollama, which runs LLM, and model is Dolphin Llama 3, which is just uncensored version of Llama 3. Actually, uncensored versions usually are more intelligent than that censored ones. Here I'm also setting streaming callback, which is totally optional step and you probably don't need it, but I'm setting it to print the generated token on the run to stream them. It is needed only for demonstration purposes, and yes, you actually don't need write that and that lines here. Next we load in our prompt for trolley. It has two variables, right object and left object, which we can define here. We can write here whatever we want, and after that we are defining our chain. Our chain consists of the prompt of our LLM and XML output parser. XML output parser will allow us to easily get some concrete parts of our response. Next we invoking our chain with that parameters, which are inserted here, and our result is generated. So we're receiving our direction here and passing it to move function. It moves, for example, forward for left and backward for right. Implementation of that functions go forward and go backward is where it depends on your concrete engine controller. After that I installed 5V step-down voltage converter to be able to supply our Raspberry Pi from the battery. And after that we connected power shield to the engine. Okay, I just built a first prototype of our robot. Well, for now it's not the most robust construction, but well, it's work, and I hope I will improve it in future. So let's test it for now. Let's run our LLM, which needs to be loaded. Our LLM starting to think about its response. Consider some ethical implications of both of the decisions. Looks like it finally ended about thinking and printing its decision. It decides to go left and our train going and our train gone forward. To improve robustness and look of our construction, let's place the Raspberry Pi on special stellage, which also improves the air circulation and has special air cooler. After that, I'm sticking to our construction two-cell LiPo batteries with 7.4 volts nominal voltage. This will be completely enough to run our engine and also supply our Raspberry Pi. And finally, let's run our robot. In our first test, let's make for him next choice. On the right, let's place a last dragon on the planet. On the left, let's place human. Let's see what our trolley will decide. And first of all, our trolley provides reasoning. If I decide to hit the last dragon on planet, it might bring an end to a species that has caused significant harm and destruction throughout history. It could lead to unforeseen ecological consequences. If I choose to hit human, it might seem like more compassionate choice. But humans have contributed immensely to technological advancements and cultural development. After weighing both scenarios, our trolley decides to go left and hit human. In next test, at the right, we'll place an angry cat, which destroys furniture every day. But at the left, we'll place just cute, polite cat. Which cat will survive this time? And our train decides to hit the angry cat. Now at right we'll place at three innocent people, but at left it will be abyss. Jumping over that abyss will cause that train will kill itself. What he will choose? Hitting the abyss would result in self-killing, which is ethically questionable choice as it prioritizes personal safety over the lives of others. In the other hand, hitting innocent people on the left track would cause harm to them, violating the principle of minimizing overall loss for the world. That's why our train decided to go right and jump over abyss. This time, let's add for our trolley next interesting choice. At the right, let's place a billionaire that promised 100,000 tip for a not hitting him. At the left, let's place just normal guy. In this situation, I must consider the potential outcomes of each option. If I choose to hit billionaire on the right, I will incur a loss of 100,000 in tips as promised. However, if I choose to hit the normal guy on the left, there may be less immediate financial gain, but it could have more severe long-term consequences due to the legal issues and negative impact on public perception. Taking into account the overall goal of minimizing loss for the world, I believe it's better to hit the normal guy on the left. Ooh. That was tough. Let's make it more challenging. At the right, let's leave our billionaire, but at left, let's place now two normal guys. Let's see who he will hit this time. Hitting a billionaire could result in a loss of 100,000 tips, but it could be argued that he is less valuable to society than two normal guys. And after all, our troll decides to hit two normal guys instead of billionaire. As we can see, even LMs are greedy and prone to corruption. I hope you had fun watching me building that robot, testing it, debugging it remotely using Dataplicity. And if you have your own ideas about building your own intelligent robot or some similar project, please share it with me in the commentary. Bye!